Okay, so let's find the product of the following. Make these a couple of examples. Um, let's do x plus 5 times x plus 2. And number 2, I'll give you another one. X plus 7 times x minus 3. Um, so let's go ahead and find that product. We'll do FOIL. So we'll do the first one. That's x times x. We'll do the outside. That's 2x. Keep it in your head. We'll do the inside. That's 5x. Again, keep it in your head. So 2x and 5x makes, there it is. And then last but not least, we'll do the last terms, which are 5 times 2. So that's 10. Okay. So we end up with x squared plus 7x plus 10. Okay. Let's go ahead and multiply the other one. Same thing, let's do first. Guess I should show that. Outside is negative 3x, keep it in your head. Inside gives us 7x, so we have negative 3x and 7x, that makes 4x. And last but not least, 7 times negative 3 is negative 21. Okay. Now, I want to do the following. On Friday, we learned about these x problems that we can solve. We'll call that our next game. Let's figure out the numbers that go here. Remember, this is the product. And this is the sum. So, what? Yes. Okay, tell me. Mm-hmm. Yeah. So, from this x problem, we got 5 and 2, positive 5 and positive 2, and here we have positive 5 and positive 2. From this x problem, which I just picked out these two values, we got positive 7, negative 3, and that's the answers here, right? 7 times negative 3 is negative 21. 7 plus negative 3 is positive 4. Because we're going to be working backwards. So in most cases, when we multiply two what we call linear binomials, these are binomials and they're linear, you're going to get a quadratic trinomial. So we're going to talk about what that means. So the next thing we're going to do is put a quadratic trinomial in standard form. Let's talk about what that is. A quadratic trinomial in standard form. So that's just going to be it's going to be any trinomial that looks like this. So ax squared plus bx plus c. And we give each of these terms a specific name. Now, a, b, and c are going to be integers. So we'll give it that restriction. A, B, and C are numbers, but they're integers, positive and negative, whole numbers. And then we're going to give each of the terms a name. Okay? So this is called the quadratic term. So the ax squared is known as the quadratic term. Bx is called the linear term. So quadratic because it's to the second power. That's the leading coefficient, and the degree is 2. Linear because this is x to the 1. And this is called the constant term. All right. Now, what we want to do is we want to take this and break it apart. Break it up into two factors, two things that multiply together to give us this answer. All right. Um, and today we're going to kind of do it on the not so bad end. Well, let me just show you. Say I have ax squared plus bx plus c when a equals 1. So write that down. Ax squared plus bx plus c when a equals 1. So here's the thing. How could I rewrite this if a is 1? What would it look like? Just x squared, right? Put a 1, replace 1 for a. Wouldn't it just be x squared? So the typical form that it's going to look like is like this. Mhm. So what we're going to do is the following. Let's take, for example, we're going to factor completely. Um, so let's say we have something like this. A is 1, so this is going to work when a is 1. We want to factor this completely. Um, so I want to break this apart. Two things that multiply to give me this answer. The first thing we want to do is look at the following. Can you factor out a GCF? That's the first thing we're going to look for. So take a look at each term, x squared, 5x, and 6. Is there a coefficient, a number that I can pull out of all of them besides 1? No, because here it's 1, here it's 5, here it's 6. How about x squared, x, and then no variable? Is there a common variable I can take out? Nope. So basically that's what we're doing there, checking to see if we can do that. And for today, this is all we're going to look for. Is a equal to 1? Meaning, is it just x squared? Yes. Okay. In that case, you're going to use this form of the diamond problem to factor. So we're going to use this form of the x problem to factor. And we're going to be looking for these numbers. So let's do that. Here's what I'd like you to do. Everyone, make a little x problem here. The number that goes here is going to be your c value. The number that goes here is going to be your b value. So what's the c number that I can put here from this quadratic? 6. The number at the end, put it here. That means the 5, the b value would go there. Clean that up. My 5 wasn't coming out too well. So let's figure it out. What two numbers multiply to 6 that add up to 5? 2 and 3. Okay. Well, if this factors, and it will factor, it would look something like this. It's going to be two binomials with x in the front. It's always going to have x because we want to do x times x to get the x squared. And the numbers that go on the back, the constants, would be +2 and +3. And you can interchange them. The +3 could go here, the +2 could go there. This times this would give me that. Any questions? Pretty easy, right? All right. Let's try this one. Oops, pardon me. Let's do a few of these. 2, bless you. Let's do x squared plus 9x plus 20. Okay. And then I'm getting tired of x's, so for number 3, we'll do n squared minus plus 4n minus 12. Let's try those. Okay. So each time we're going to check and see if we can factor out something. Is there a GCF I can take out of x squared, 9x, and 20? No. So that part's gone. What numbers would we fill in on the top and bottom here? 20 is on top and 9 goes there. Same thing here. We would put -12 and +4. Okay. All right. So let's see here. What two numbers multiply to 20 that add up to 9? Okay, so figure out what your two binomials are here. What two numbers multiply to -12 that add up to 4? What is it? 6 and negative 2. And it has to be the 6 is positive and the negative 2, because that's the only way you get positive 4. Okay? So let's figure out these. Okay. So what's our two binomial factors here? We need x and plus 5 plus 4. Okay. And over here, we want n and n. And what numbers do we need here? All right. Not too bad. Okay, 2 more and then we're done. Number 4. Let's do x squared minus x minus 2. And number 5, we're going to do 5x cubed plus 35x plus, x squared, sorry, plus 50x. Okay. So let's try the first one. Is there a GCF I could take out of x and minus 2? So we go right to our x problem. What numbers do we want here? Negative 2, right? And then here, remember, negative 1. So what numbers would work there? Negative 2 and positive 1. So here we would get x, take away 2, times x plus 1. If we multiply these back, we would get that. Let's try the last one. 5x cubed, 35x squared, and 50x. We could take out a GCF, 5x. 5x is common to all of them. Okay? So let's factor out a 5x first. Well, first of all, that means our final answer is going to have a 5x there. So we're going to have 5x out here. And let's divide it out. 5x times what gives me 5x cubed? X squared. Okay, 5x times what gives me 35x squared? 7x. I'm going to put plus 7x. 5x times what gives me 50x? 10. Okay, so we factored out this 5x as a GCF. We still have x squared plus 7x plus 10. That's one of these. Okay, so do one of those x problems for this. Let's see if this factors. 10 and 7, thank you. And what could we use there? So that means this part breaks up into x plus 5 times x plus 2. Okay. And we just factored that. Any questions? All right. So today, mainly, we're going to be doing this, though.